Mind blown! The James Webb Space Telescope has uncovered ancient supermassive black holes that defy explanation. Peering back to just 670 million years after the Big Bang, Webb spotted a monstrous black hole when the universe was only 5% its current age. How did these massive beasts get so big so fast? Get ready to have your mind blown as we explore Webb's revolutionary discoveries, rewriting the black hole rulebook and uncovering their dark secrets. The Space Telescope revolution is here. I hope you will enjoy this video. If you do, please subscribe to my channel for more mind-blowing space content as the Webb discoveries continue. In July 2022, the James Webb Space Telescope delivered its first groundbreaking discovery, detecting a supermassive black hole from just 670 million years after the Big Bang. To put that in perspective, when this ancient black hole existed, the universe itself was only 5% of its current age. So how did Webb manage to spot something so incredibly ancient and distant? It used a technique called spectroscopy on the galaxy the black hole resides in. By breaking down the galaxy's light into its spectrum of wavelengths, Webb was able to analyze its redshift. Redshift is a measure of how much an object's light has been stretched by the expansion of space. The higher the redshift, the further back in time we're looking. In this case, the galaxy had a redshift of 12.5, one of the highest values ever measured. This indicates we are peering back to within just 550 million years of the Big Bang itself. Now here's where it gets really interesting. This black hole is estimated to have a mass of about 10 million suns. That might sound pretty hefty, but it's actually smaller than other supermassive black holes detected from a similar era. This raises a critical question. How did these gigantic black holes grow so massive in such a short span of the young universe? The typical timescales for black hole growth don't line up with current models and theories. Clearly, there must have been other unknown mechanisms or processes occurring in the early universe that allowed these monsters to achieve such enormous sizes so rapidly after the Big Bang. Webb was able to make this detection because of its unprecedented ability to see incredibly faint and distant objects in the early universe. This allows us to directly observe the cosmos at an epoch we've never before been able to access. Webb also found clues about the black hole and the properties of the galaxy itself. It was extremely bright in infrared wavelengths, indicating the presence of an actively feeding supermassive black hole surrounded by a hot accretion disk. The galaxy was also forming stars at a rapid rate. This is likely related to the close interplay between the growing black hole and its host, with the black hole's energy injection triggering enhanced star formation through feedback mechanisms. This discovery highlights the deep connections between black holes and their home galaxies, even dating all the way back to the earliest ages of cosmic history. In November 2022, the James Webb Space Telescope made another bombshell discovery, detecting signature molecules swirling around actively feeding supermassive black holes. JWST identified the presence of polycyclic aromatic hydrocarbons, or PAHs, in the accretion disk surrounding three black holes up to 370 million light-years away. This was an incredibly surprising find because scientists previously thought the intense radiation emitted near an active black hole would destroy any molecules like PAHs. So how did Webb detect them? Using its specialized infrared spectroscopy instruments, it identified the distinctive infrared signature of these molecules based on their brightness and color. JWST was essentially able to take chemical fingerprints of the environment around these black holes. It measured the size, shape, charge, and temperature of the PAHs based on their light spectrum. This granted astronomers an unprecedented, detailed understanding of the turbulent environment within these accretion disks on the brink of the black hole's events horizons. The presence of these PAHs also provides important clues about the star formation rates and physical conditions inside the disks, swirling with hot matter destined to fall into the black holes. Additionally, this discovery directly challenges previous models predicting that no molecules could survive near the intense radiation of an active galactic nucleus and its supermassive black hole. There are more complex chemical interactions and processes happening in the extreme environments around these black holes than we realized. The team also found differences in the properties of the PAHs compared to those found elsewhere, providing evidence that they are altered by the black hole's radiation. Overall, this research demonstrates the immense power of James Webb's specialized infrared spectroscopy instruments to unveil details of cosmic objects that were simply impossible to observe before. By better characterizing the turbulent environment near supermassive black holes, we can gain critical insights into the impact these dark monsters have on their host galaxies. This includes effects on star formation rates, gas flows in and out of the accretion disk, galactic chemistry patterns, and more. JWST is ushering in a new era of understanding active galactic nuclei and revealing the secrets of the chaotic world at the edge of black holes. The James Webb Space Telescope recently conducted a deep survey of ancient galaxies in a region called the Extended Growth Strip. Astronomers expected this cosmic census to uncover a wild zoo, numerous supermassive black holes rapidly feeding and blazing as active galactic nuclei. But JWST revealed a more peaceful universe than models predicted. Rather than chaotic regions with rampant black hole growth, the early cosmos appeared remarkably stable and calm. What explains this major discrepancy between predictions and observations? Theories point to supermassive black holes growing at a slower rate than previously thought. Additionally, lower mass black holes accreting at more languid paces are likely difficult for even JWST to detect. This suggests the early universe may have been more orderly than expected, with less turmoil from quickly ballooning black holes disrupting their surroundings. These slowly feeding black holes seem to have had less dramatic impact on their host galaxies compared to the most extreme active galactic nuclei. Their more moderate feeding habits kept the energetic radiation and feedback effects in check. JWST's survey provides an important baseline for understanding how black hole feeding rates have evolved over cosmic time. Combined with other observations, we can now piece together the life cycle of these cosmic beasts. It seems supermassive black holes go through long periods of slow, steady feeding, interspersed with intense bursts of accretion activity. This start and stop cycle plays out over billions of years as the black holes and their host galaxies dance together through space. These insights lead us to rethink theories of how supermassive black holes grow and influence their galactic homes. JWST's observations will help refine models to better match measured reality. We can also see connections to black holes in our local universe, like the quiet giant Sagittarius A* at the heart of the Milky Way. Was it also an active galactic nucleus in the galaxy's past? Understanding the growth patterns of these dark monsters is key to unraveling their role in the evolution of the early universe after the Big Bang. JWST has begun piecing together the story, but many exciting revelations still await. The James Webb Space Telescope has shattered records by finding the most ancient supermassive black holes ever detected. JWST's observations are rewriting theories about early black hole growth and providing unprecedented insights into their chaotic accretion environments. As Webb continues surveying the infrared universe, we will gain the most detailed view yet of these dark monsters from cosmic dawn. Exciting revelations lie ahead as JWST operates at full power. What black hole mysteries do you hope it will uncover next? Don't forget to hit like, subscribe, and ring the bell to join me for more epic space discoveries. What did you think of these mind-blowing black hole revelations? What questions do these discoveries raise for you? Let me know your thoughts and what you want to see next from the James Webb Space Telescope. This has been Specticosmos. Thanks for watching, and see you soon for more amazing space videos.